Hello friends, Uncle Lee here with a little discussion on solving some logarithmic and exponential equations. We're simply going to go through a few examples that you'll be able to go through yourself and do some of your assignments. So let's start off by solving a very simple logarithmic equation. So I have log base 5 of 2x plus 3 is equal to the log base 5 of 3. Now since logarithms are a one-to-one function, these are the outputs of a logarithmic function. And if you have an output of a one-to-one function, that simply says that there's only one input that goes to each output. Therefore, I can very simply say that, hey, that implies, this equation here implies that 2x plus 3 is equal to 3. Must have the same input. If the outputs are equal, you must have the same input. Therefore, 3 has to equal 2x plus 3. Simple little algebra 1 equation, or pre-algebra equation, if you will. X is equal to 0. Example number 2. Example number 2, a little bit more difficult right there. I got log base 2 of x plus 7 plus log base 2 of x plus 8. That has to equal 1. So what we're going to do is use the laws, the properties of logarithms that we've discussed the last 2 days, and we're going to combine these two log base 2 creatures there, and I can only do that since I have the same base here. And if I remember that property, if I have log base a of m plus log base a of n, that's going to be log base a of m times n. So that I believe that's property number, don't know what property it is, but it is a property of logarithm. So just multiply those together. If you're adding a logarithm of the same base, you can multiply the creatures that you are logging. So now I have log base 2 of this product that's equal to 1, and now I'm just going to employ the definition of the logarithm. That tells me 2 to the first power is this product right here, x plus 7 times x plus 8. And now we're back to an algebra a fairly simple algebra 2 problem. So 2 to the first power is 2, multiply that out. Here I have a quadratic equation. How do I solve a quadratic equation? Yes, set it equal to 0, set it equal to 0. This is a nice one that factors. You may encounter one where you have to use the quadratic formula. Fear not, just use the quadratic formula. This one, however, does factor. X squared plus 15x plus 54 is equal to x plus 9 times x plus 6. Zero product property tells me that x is equal to 9 or x is equal to negative 6. So that's the solution to this particular logarithmic equation. Okie dokie. Next example. Oh, wait a minute. Not so fast. Not so fast on that particular solution. We better check our answers to see if they actually are reasonable answers, if you will. So if I try x equals 9, here's my original equation, and if I put x equals 9 in there, right off the get-go, I get log base 2 of negative 2, which is an error. That cannot happen. You can only log positives. So that if you put the negative 9 in there, you're going to get log base 2 of negative 1, which also is an error. Cannot happen. So this is an error. So x equals 9 is not an answer, so the only answer to this particular equation is x equals negative 6. And if you put negative 6 in there, you're going to get log base 2 of 1. Let's just do that. If you put negative 6 in, you're going to get log base 2 of 1 plus log base 2 of 2, and that's supposed to equal 1. Oh, and it does. What's log base 2 of 1? That's, yes, by properties of logarithms, or by definition, that's 0. 2 to what power is 2? 1. And the last time I checked, 1 does equal 1. Only solution here, x equals negative 6. Now let's go on to the next. So, moral of the story, check your answers. Whenever you're solving a logarithmic equation, you better check your answers. Next example here. Oh my goodness, now we're back to an exponential equation. This particular equation, although it's found later on in our chapter, this one we were solving as soon as we started going over exponential equations. If I have 5 to the negative x is equal to 25, 25 clearly is 5 squared. I have like bases. One-to-oneness of exponential equations. That says that negative x has to equal 2, therefore x has to be negative 2. That's an easy one. Let's go to the next example. Oh, 3 to the x is 14. That means I have to write 14 to a power of 3. Not possible here. So what we're going to do, and this is something that we do in calculus a lot. I'm not sure if our textbook is going to solve this problem in this way, but this is how we are going to solve this problem. What we're going to do is just to ln both sides. We're going to use the natural logarithm and we're going to ln both sides. I can do that, again, because the natural logarithm is a one-to-one function. And that's a true statement. If this is a true statement, this has to be a true statement. Here I have the same input. If I believe this equation to be true, I have the same input. It's going to give us the same output. So that's a true equation. I'm going to ln both sides. This is a hint, or this is a method that we will use a lot next year in calculus. So now at this point, I'm going to use that property that I said was going to be very prevalent in solving logarithm equations. And if I have log base 3 to the x, I'm going to bring that x down in front. So now I have x times ln of 3 is equal to ln of 14. Simply divide by ln of 3. And x is equal to ln of 14 divided by ln of 3. And that's the precise, exact mathematical answer. If you want to estimate this to 3 decimal places with your calculator, you could. That's correct. Okie dokie. So if I have an exponential equation, I can't write 14 as a power of 3. I ln both sides, use the property of logarithms, solve it as I would any equation of this type. X is equal to ln of 14 divided by ln of 3. Next example. Again, here's an exponential. Oh, this is a nasty one right here. This is definitely a nasty one. We have a couple of these to do in our homework assignment. So I have 3/5 to the x is equal to 7 raised to the 1 minus x power. And there's lots of different ways that you can approach this problem and get the correct answer. What I'm going to do is ln both sides. Same way I did on that last equation. So now I have the ln of 3/5 to the x power is equal to ln of 7 to the 1 minus x power. This is 7 to that power. 7 to that power. So I'm ln'ing that creature right there. And I'm ln'ing 3/5 to the x. That tells me that I can use that property and put this guy down here in front, and I can put this whole creature down in front of ln of 7. As that. It's going to be nice and easy if I just write 3/5 as 6/10. And so now I have x times ln of 3/5, or 6/10, is equal to this whole creature right here, 1 minus x times ln of 7. And now my object is to solve for x. People struggle with the algebra here. So what we're going to do is we're going to multiply this ln of 7. We're going to use the distributive property. Multiply ln of 7 times 1. Multiply ln of 7 times x. And we're going to get, I still have x ln of 0.6 is equal to ln of 7 minus x ln of 7. Now I want to solve for the x's. So I'm going to take this creature and move him over here with this side because I have an x here. So I'm going to add x ln of 7 to both sides. That's going to give me x ln of 0.6 plus x ln of 7 is equal to what's left over here, ln of 7. This guy here moved over here. And now I'm going to factor the greatest common factor out of this dude right here, which is x. I have two terms. To factor out the x. And I have x times quantity ln of 0.6 plus ln of 7 is equal to ln of 7. Simply divide by that. Then I get x is equal to ln of 7 divided by the sum ln of 0.6 plus ln of 7. That, ladies and gentlemen, is a scary problem. And people don't like that problem. That's a type of problem that you definitely will have to practice time and time again. So if we go back and look at the entire problem, several steps there, I would suggest that you pause the video, go through the steps, rewind the video, go through the steps one by one. This is a scary problem, a good problem nonetheless. Let's go to our final example here. And we have this guy right here. This again is a nasty little problem. Not nasty, this is an easy problem. This is an easy problem if you know the correct method. If you don't know the correct method, you could be looking at this problem for days upon days. So I have 36 to the x minus 6 times 6 to the x is equal to negative 9. What I'm going to do, right away I see that 36 is a power of 6. Actually, 36 is 6 squared. So I have the quantity 6 squared to the x power minus 6 times 6 to the x, and I'm going to add the 9. And you'll know why here in a minute. Add the negative 9 to both sides, so I have this plus 9 is equal to 0. Now what I'm going to do is I'm going to write 6 squared to the x as 6 to the x squared. If you remember the laws of exponents, a power to a power you multiply, so this would be 2 to the x. 2 times x is the same as x times 2, so I have 6 to the x squared is the same as that, minus, I still have 6 times 6 to the x, plus 9 is equal to 0. What I'm going to do, and this is a trick that we do a lot in calculus, is we're going to do some substitution here. And I'm going to let u equal 6 to the x. So I'm going to put u in for this dude, and I'm going to put u in for this dude. What's that going to give me? That's going to give me this equation, this quadratic equation, u squared minus 6u plus 9 is equal to 0. This is an easy quadratic equation to solve. That thing factors into u minus 3 times u minus 3 is equal to 0. What does that tell me? That says that u is equal to 3. Well, what is u? Keep in mind that u was 6 to the x power. So if u is 6 to the x power, that says 6 to the x is equal to 3. Now I have a simple exponential equation that I'm going to solve using logarithms. ln both sides, I got ln of 6 to the x is equal to ln of 3. The x comes down in front, that 3 actually is here. Kind of up in the air a little bit. The x comes down in front, divide by the ln of 6, and x is equal to ln of 3 divided by ln of 6. Again, this is not a very happy problem, but nonetheless a very important problem. What I would do is look at the problem and the complete picture of the problem. Again, got a lot of steps here. It's another reason why math students are like it, multiple steps. What I would do is rewind this particular problem, go over it step by step. You're going to use this process of u substitution a lot in calculus. So I've gone over several examples, and you're going to find these examples on the assignment and certainly on your quiz that you're going to take after you watch this assignment. Thank you very much.